Hello everyone, welcome to the GeoEcologist. I am Dr. Krishnanand and you have been watching my videos on various topics of geography, environment, disasters and several other topics on our channel, the GeoEcologist. If you are a new subscriber, please go to the playlist section and definitely check the earlier videos. Now in today's video, we are going to start a new topic that is related to hydrology. So this series on hydrology we are doing on your requests, and several of you have requested in emails and comments in earlier videos that please make a series on hydrology. So here we are beginning hydrology lectures today. So in this first lecture on hydrology, we are going to look into the introduction to hydrology, the basics, concepts, nuances, the basic idea of how hydrology has been looked by various sciences and what is its role in geographical sciences specifically, and also looking into the various dynamics. So all these things are going to be discussed in this particular session, and also there is a surprise in the end. So do watch the video till the end, where we'll be looking into what we are going to do in the future as well. So please do subscribe, do share these videos, and let's see that how many views come on this particular video today. So let's go ahead and learn. So now let's understand this introduction to hydrology, and let's begin with the basics. So etymologically speaking, hydrology is coming from the Latin word you see here is logos, logia, which basically means the scientific study, and hydor is from Greek, which basically means water. So basically scientific study of water and its various components. But wait, it's not just that simple. So in definitions, if you want to look into hydrology, it's basically a scientific study of movement, distribution and quality of water. Three things you should remember: movement, distribution and quality of water on Earth's surface, and also related to water cycle, water resources and environmental sustainability, where you see in sustainable development goals, water is the key component, isn't it? And then the question is, who is a hydrologist? So basically, a hydrologist is a student or a person who practices or studies hydrology itself. And also remember, there is a confusion amongst people that hydrology, oceanography and also meteorology are combined. Remember, hydrology is a different subject altogether, and oceanography is different and meteorology is different. Although they are interlinked, but they have their specific domains of research and domains of work. So understanding of hydrology could be found better if you understand what hydrologists do and what is the design and operation of applications of hydrology. So if you observe applications of hydrology, you see the study of hydraulic structures, water supply, wastewater treatment, then you have irrigation, drainage, hydropower generation, flood control, navigation, salinity, pollution, recreational usage of water, wildlife, flora, fauna, all these interlinkages. So do you see any linkage to geography here? That's why we say geographical hydrology has to be looked into, because it's a distribution way we talk about on space, right? So we need to map what are we learning in the hydrology. Now let's look into the basics of hydrology. As I told you, this is the first lecture, so things that you would already know, let's brush up. So first thing is our hydrosphere. So if you look into the component-wise analysis of our hydrosphere, what do you see? Total global water. Oceans are 96.5%, many places you see 97% approximation. And what about the rest of the 3%? So you see saline lakes is 0.07%, saline groundwater is 0.93%, and fresh water is just 2.5%. Right? And fresh water is what is the most important for human beings, for us. And out of these, if you observe 2.5% of fresh water, you will observe glaciers and ice caps are 68.6%, almost 67%, and groundwater is 30%, right? And then you have surface water, which is merely 1.3%. So if you observe what's happening again, from the surface water, you have ice and snow 73%, lakes 20%, and then you have atmospheric water, biological water, rivers, swamps, marshes, soil moisture. And this is where we are concerned in hydrology. We're talking about all these kind of components where water is distributed. So looking into the world picture, have you seen these images where water bodies have been listed on maps? You can pause the video here and look for all these water bodies. So you have all the seas here of the world, oceans of the world, gulfs of the world, and you can map it yourself, right? Then what you observe is rivers of the world as a basic idea of hydrology and its distribution across the world. So this is on land. If you observe here, all the rivers have been listed the major ones, of course, and you can pause the video and you can look into these rivers across the continents. Now, why did I show you the world map of oceans, gulfs, bays, rivers? Because you understand these are the broader framework of studying hydrology or surface hydrology. Now, looking into this, the word here is that it is a climate ameliorator, that it's the basic regulator of life forms on Earth, isn't it? So without water, we cannot imagine life. So that's why we say that all the forms of water are very important for our habitat. And that's why we observe that it's very human-centered concept of hydrology that we also talk in geography. Now let's understand branches of hydrology further. So in branches of hydrology, I'm sure you must have heard of some branches. Chemical hydrology, where we study chemical characteristics of water. And then what we observe here is eco-hydrology, which is upcoming paper, and you understand in eco-hydrology a lot of things have been talked. That is where living beings, the ecology is supposed to be looking into, and its interactions, material and energy exchange, hydrological cycle alongside the flora and fauna. And then what we observe is hydrogeology. So here again, interdisciplinary study. Geology is everything that is concerned below the earth's surface. So here you have presence of underground water. Then what you observe is hydroinformatics. Now joining the system of informatics, which is information technology, new technology related to hydrology and their applications, where satellite technologies, ground penetrating radars and several other things have come up into the picture. Now you observe hydrometeorology. It's talking about atmospheric sciences together with hydrological sciences, right? Then what we observe is isotope hydrology, very important. So isotopic signatures of water, isn't it? Very important. I'm sure you have heard of heavy water and others, especially in context of nuclear reactions and several others. Now, surface hydrology, which is basic domain of geographical hydrology, where you have all the processes and its distribution and all the mapping done. So these are basic branches. And then you have drainage basin management, where management of all these water storage, water systems, flood protection, reservoir creation and recreational facilities creation are concerned. So these are the branches of hydrology, and many times one branch of the hydrology is also linked with the other branch to give you a solution to a problem. Now, coming to water quality, which is the last portion, where only quality assessment of water, especially in urban studies, have been separated out from hydrological sciences, and its pollution and natural solutes, sources, and all these things are discussed here in terms of quality. Now looking into hydrological science that deals with the processes governing these depletion, replenishment of water resources. So you observe the understanding of water cycle. Now in slightly extended words, if you want, hydrology can be described as a science that deals with waters above and below land surface. But when we say below land surface, it's largely geological. So hydrogeology comes into the picture. But remember, relation to human beings are where we are focusing right now. Now, let's look into the elements of hydrology and other geosciences. This flow diagram would help you to understand it in a better way. So, hydrology has a link to atmospheric water, ocean and marine water, snow and ice caps, groundwater, surface water. And here you have runoff, and then you see this is the entire cycle which is here. Now if you observe applied hydrology, application of this hydrological process, its distribution and the knowledge about it, it has to be where? In terms of water supply, flood control, irrigation, recreation, electricity production, soil conservation, and several other domains. And I'm sure in the new world, new words have been put in terms of hydrology. So one word I'm leaving you with is to understand what is virtual water. So if you have any idea on what is virtual water and how it is related to hydrology, do comment in the box. Now, let's go into the water cycle. I'm sure since your childhood you have seen this water cycle called hydrological cycle or biogeochemical cycle, where the continuous water changes its forms and circulates in the system. So there are certain words. Again, just take a revision of these words right from the evaporation, precipitation, condensation, transpiration, infiltration, then you have subsurface flow, percolation. All these words are to be revised and put into the picture. So now, First thing that we talk about is the inputs of the system in hydrology. So what are the various inputs? Where the water is coming from? So main input is precipitation. And if you want to look into the characteristics, here it is. So what are the various forms of input? So if you look into rain, snow, hail, and several others, then you have amount of input, then you have intensity of input, then you have seasonality of input, and then you have distribution of input. So what are the keywords when you talk about inputs? You can make a flow diagram for yourself. Form, amount, intensity, seasonality, and distribution. Then if you observe, the second important component is flow. So when there is an input, there is a flow as well. So what kind of flows are we talking about? So let's look into it. Interception, right? Then you have something which is intercepted. When water falls in the ground, it is intercepted by several components which are available on ground. So interception may be by trees, by soil, right? By grasses. Then you have infiltration, where water is soaked into, absorbed into the soil. Then you have percolation. So water is going inside, percolating through permeable rocks. Then you have through flow, groundwater flow, surface runoff, which is also called overland flow, and then you have river or channel flow. So these are the flows involved in hydrology. So you can pause the video, and again, if you want, you can make a flow diagram or you can write it for yourself. Also, we'll be publishing ebooks on the same content. So if you don't want to write it right now, you want it for yourself, you can order it later on. Now looking into the outputs. So you have input, flows, and then you have outputs. So how the water is going up again in the atmosphere? Through evaporation, transpiration, and also there is something called discharge, which is very important component of the quantitative hydrology. As we go into the lectures, you'll understand what is all this. So hydrological system has all these components listed here. Now, what was the surprise that I told you in the end? I have made a glossary of certain terminology in hydrology for you. So look into these words and its definitions. For example, hydrogeology. Who gave the word itself? Mead in 1919. So this term was given by Mead in terms of the branch of earth science that deals with occurrence and movement of subterranean water below surface. Right? Same thing was again repeated, but in a different way, in a different perspective, where geo came first and hydrology later by Minzer in 1942. So this is geohydrology, although talking about the similar things, but in a different way, where perspective is majorly the ground and accordance with that, the hydrology. Then what you observe is the measurement, and you observe these devices. So these devices which hydrologists use for measuring various parameters of hydrology, I have listed it for you at one place. So look into disdrometer, precipitation; Simon's evaporation pan, evaporation; infiltrometer, infiltration; piezometer, so measures groundwater pressure; radar, cloud properties; then you have rain gauge, which is rain and snowfall; then satellite; sling psychrometer, which is to measure humidity; then you have stream gauge for stream flow; tensiometer for soil moisture, and time domain reflectometer for soil moisture. So these are certain words, certain terminology which I have listed at one place. These are basically what? These are the instruments utilized for measurements. And now there are certain fields or subfields of hydrology, or you can say it has an interdisciplinary linkage with these fields. So just take a look into it. So aquatic chemistry, of course, the chemistry part of it, and then you have hydrology coming together. Then you have civil engineering involved in all these draining swamps, municipal sewage disposal, flood control, irrigation, and all these measures. Then you have climatology, and if you have studied geography, you understand climatology is the core component of geography, especially physical geography. And then you have environmental engineering, where waste reduction, then you have sanitary engineering, polluted sites and its remediation being done these days. Then you have physical geography, geomorphology, which has a close association with hydrology. Then you have hydraulic engineering, which is part of the civil engineering, where you have dam construction, canal construction being done, and several others. Then you have limnology. Remember, lakes study, inland water lakes, saline and freshwater lakes, right? Turbid water lakes. So this is limnology, where lakes, ponds, rivers are being studied. Then you have oceanography, of course, where you have an interlinkage. Now, looking into the three major words here, as I told you that these words are not discussed generally. So let's discuss in the first lecture in introduction itself: infiltration, percolation, and seepage. Do you see the diagram? Here infiltration is on the surface, here it is infiltrating. Then further you have a rock layer where you have percolation, and then you have something called the seepage. So seepage is which is here. So let's look into these words one by one. So infiltration is the process by which water on the ground surface enters the soil, right? Simply entering. So measured in inches per hour or millimeters per hour. Then what you have is percolation. Here percolating is a phenomena, it's a process. The Latin word percolare basically is to strain through. So there has to be a medium which is there in between and water is straining through. So usually it is slower. Then what is there is seepage. So where liquid is leaking, leaks are related to seepage, where movement of water is not restricted to vertical direction. So it is the slowest. So remember, infiltration, percolation and seepage as three distinct words in terms of hydrology. Now, looking into certain different words, I told you I have made a glossary. So fluvial deposits, heterogeneous deposits, homogeneous deposits and floodplain. This is related to fluvial geomorphology. And if you have not watched the video on fluvial landforms, you can go to the playlist and you can watch it there. So these deposits are brought by river, stream. Heterogeneous is the composition is in diversity, and then homogeneous is same kinds of deposition, and floodplain is the entire huge plain created by the river deposition. Then you have something called potentiometric surface. Do you see this particular surface? This particular line, this average line that you see here, this line is called potentiometric surface. What does it mean? It's an imaginary surface representing the static head of groundwater in tightly cased wells, that is aquifer. So it is basically talking about that particular line which is here, which is like a tightly cap. So if you have a cap which is across, somewhere it is high, somewhere it is low, so an average line. So that's why we say it is a potentiometric surface used in hydrological studies. Now, aquifer. So look at the word, a formation or a group formation or part of formation that contains sufficient saturated permeable material to yield sufficient, always remember the word sufficient quantities of water in wells and springs. This is called aquifer. Then what you have is aquiclude. So geological formation or part of a formation through which virtually no water moves, that is called aquiclude. Do you see this here in the image also? Aquiclude. Then what you have is aquifuge. So aquifuge is also a geological formation with low permeability and porosity. So this is very important. Now look into aquitard. So the word aquitard is used for poorly permeable bed that does not yield water freely. So the bedrock which does not have any water table here is aquitard. So remember these particular words. Now come to the word perched water. Water and perch, birds perch, they sit on the top of a tree. So perching, look at this particular, here is the main water table, aquifer, and it is perched water table, which is beyond the unsaturated zone. So this is called perching. Then what we observe is piezometric head, piezometric surface. So these are the piezometers that you observe here, where you have the confined aquifer and you observe them through the device called piezometer. Then what you observe is elevation potential head, which is height of any particle of water above a specified datum, that is talking about a potential energy. Now let's look into the artesian well. A well obtaining its water from an artesian or confined aquifer is called artesian well. Flowing artesian well, obviously here the flow is involved. So you can look into the images yourself and see these words. Remember these words because these words will again and again come into the discussions in the lectures to come. And remember hydraulic gradient. Wherever there is a gradient, it's talking about the degree of slope. So you observe hydraulic gradient here and you see this is what we talk about from A to B, what is the gradient, and this is how it has been calculated in the direction. Then equipotential lines, the word itself tells you equal potential. So it's like making a contour line as per the pressure gradient. Then you have flow lines, then you have groundwater catchment area, groundwater divide and recharge groundwater. So if you observe this particular line here, this is groundwater divide. Here is one river, here is another river, and this is the divide portion. So these are two catchment areas, right? And then you have the profile view which you can see here. So what you observe, the flow of the direction is different here. Then you have discharge area, base flow, then you have hydrograph. So look into this particular hydrograph here. So discharge area is where groundwater and water is unsaturated zone is released, right? And then you have base flow. So observe here, base flow is being listed here, and then this height is for storm flow. In a stormy situation, how the flow is there. So hydrograph gives us all these flowage. right? And then you have something called phreatic level, which is saturation zone also. So you observe this particular zone, which is the saturation zone of water or aquifer, and above which you have the vadose zone, right? So vadose zone is where the water is being shielded by particular soil or rock. So this particular is called phreatic level, where it is directly in contact with atmospheric pressure. So this atmospheric pressure is very important if you want to talk about phreatic levels. Or phreatic eruptions also happen, where underground water is pushing through because of the heat accumulation, and many times it is considered as geysers, hot springs, isn't it? So these are the words, and remember, we learn more in upcoming lectures. And what is the request to all of you is, do share these videos for maximum outreach. So now, when we have discussed various aspects of the introduction to hydrology in this session, in the sessions to come, as I have told you, that we are going to bring all the different topics related to hydrology, and it's going to be an extensive series. So keep watching, keep subscribed, and also don't forget to share these videos with maximum number of people around yourselves. So all the best wishes. Take care.